Hey guys, it's Mrs. D. I just want to go through a few extra problems with you if you'd like to get some extra practice over the mole calculations. And I have about 4 problems for you, and I just want to show you like what we're looking for and how things are a little bit different from maybe from Chem 1. So here we go. First of all, let's take a look at this problem. How many oxygen atoms are contained in 12.7 grams of zinc sulfate, ZnSO4? The first thing you want to think about is you need to decide if the atoms, are we looking at atoms or are we looking at the compound itself? Or are we looking at formula units? What are we actually searching for here? And so what I want you to see is that we're actually searching for the oxygen atoms. So we're searching for a part of the full compound. So we're going to do what we always have done with mole conversions is we identify what we have and what we need. And so we have 12.7 grams and we need oxygen atoms. So we always start with what we have, and we need to think about here. We have 12.7 grams of zinc sulfate. And if we go to atoms, we've got to go through moles, because remember how we did our mole equations and our mole calculations is that if you don't see the word moles, then you have to go through moles. That's a little indicator of which way we should do our problem. Apologize for the crazy lines. So my molar mass of zinc sulfate, I went ahead and calculated that, and it was 161. So we have 161 grams approximately of zinc sulfate for every 1 mole of zinc sulfate. And so once we have moles of zinc sulfate, we need to keep going because we need to get to atoms of zinc sulfate. So for every 1 mole of zinc sulfate, we have Avogadro's number, 6.02 times 10 to the 23rd. And really, we shouldn't necessarily say atoms. It's actually really formula units here because we're looking at an entire compound. Now, here's the step where we have to go a little bit further. And so if we have atoms of zinc sulfate, we're going with atoms of oxygen in general. So think about this. Think about it in the terms of compounds. We have this amount of compounds of zinc sulfate. So when we just have one compound of zinc sulfate, how many atoms of oxygen do we have? Well, we look at the compound and we see we have a subscript of 4. So we actually have 4 atoms in every one compound of zinc sulfate. Now, to calculate this, just like we would any other problem with dimensional analysis, is we multiply everything across the top, multiply everything across the bottom, and divide the 2. So I'm going to punch in my calculator. Now remember, you can use the EE button if you're comfortable, or you can just put the Avogadro's number in parentheses. But if you don't use the EE button, I would definitely encourage you to put it in parentheses. So I calculated it, and I'm at 1.90 times 10 to the 23rd. So we have 1.90 times 10 to the 23rd. Now, why did I keep that 0? Because of sig figs. Okay, we have atoms of oxygen. Look at my sig figs. I got 6.02, I have 161, I have 12.7. There's 3 sig figs there. That's why I want to keep my 1.90 for my sig figs. Let's take a look at the next problem. How many grams of carbon tetrachloride are present in 2.67 moles of carbon tetrachloride? So take a minute to see if you can solve this. Now, let's go through this. And again, we're going to identify our have and our need. So we have moles and we need grams. And so we need grams of the full compound. So we don't need to break that compound apart. So we're going to do very like what we've done in Chem 1. We have 2.67 moles of carbon tetrachloride. And to go from moles to grams, we're going to use, sorry about that. We're going to use the molar mass. And carbon tetrachloride's molar mass would be 35.5 times 4 plus 12. We're going to get 154. Okay, so let's see where my cursor is here. 154 grams of carbon tetrachloride. We're there already. All we have to do then is multiply. So we take 154 times 2.67, and we're at 411.18. Well, how many sig figs do we want to keep? We have 3 sig figs in 2.67, 3 in 154. So we're going to keep 3. So we'll just say 411 grams of carbon tetrachloride. Let's go to the next one. This one's a little bit different, and it should look relatively familiar because we have done this one similar before. We want to know how many moles of lithium are present in a sample that contains 2.45 times 10 to the 87. That is a monstrosity of a number, and that's formula units. Now, formula units may as well think about compounds. Just say I have this many compounds of lithium sulfate. So we want to get to moles, but not just moles of lithium sulfate. We need moles of lithium. So we're going to, again, start with our have and our need. So our have is what's given to us, which is 2.45 times 10 to the 87 formula units. I have to admit, guys, that 10 to the 87 is an insanely huge number, and it makes me think it's probably a typo, but we'll just go with it for the sake of numbers here. So we're going to say we know that there's 6.02 times 10 to the 23rd, Avogadro's number, formula units in every 1 mole of lithium sulfate. However, we need to know moles of lithium alone. So if we just keep on considering, if we have 1 mole of lithium sulfate, so think of it this way, we have 1 mole of La2SO4 all over the place, repeated. We have 2 lithiums for every 1 lithium sulfate. So therefore, we're going to have 2 moles of lithiums for every 1 lithium sulfate. So we're at 2 moles of lithium. We're going to multiply that out. And again, we're going to get a very large number because that 10 to the 87 is just honestly pretty ridiculous. So we're going to divide out, and we are going to get a giant number still. And so let's see, sig fig wise, we have 3 sig figs, and we really this is kind of like this 2 and 1. We just want to stick with the 3 sig figs because that 2 really is kind of like more so a mole ratio. So if I write this out for 3 sig figs, I have 8.14 times 10 to the 63 moles. Okay, think about this. Honestly, this number right here is pretty insane. And like I said, it's likely a typo because the number of moles of that is pretty ridiculous. Let's go to the last question here. So the last question says, how many carbon atoms are contained in 84.3 grams of ethene? And ethene is C2H2. And so again, we're looking at carbon atoms. So we're looking at a portion of the compound. So we always want to start though with what we have. And our have is 84.3 3 grams of ethene, C2H2. Let me there we go. So first off, in order to get to atoms, we've got to go through moles because you don't see the word moles in there. So we have 12 and 12 is 24 plus 2. We have 26 grams is our molar mass of ethene for every 1 mole of C2H2. And then we're going to get to atoms here. So for every 1 mole of C2H2, we have 6.02 times 10 to the 23rd. And since we're still working with a compound, I mean, in a sense, it's actually like we have compounds of C2H2. And so now we want to keep going because we want to know how many carbon atoms. So we look at C2H2 and how many atoms are in C2H2 that are carbon, and there's 2. So for every 1 compound of C2H2, there's 2 carbon atoms. So basically we have for every 1 compound of C2H2, we have 2 atoms of carbon. Whoops. Okay, and then we want to calculate out. So we take 84.3 times Avogadro's number times 2 divided by 26. We don't need to throw those ones in there. And so if I would calculate that out, I'm going to get 84.3 has 3 sig figs. 6.02 times 10 to the 23rd has 3 sig figs. Times 2, again, that's kind of like a mole ratio divided by 26. There's only 2 sig figs there. So we're going to keep 2 sig figs here. And so our final answer is going to be 3.9 times 10 to the 24. And that's atoms of carbon. Now, I know that doesn't seem like a whole lot bigger than 10 to the 23, but think about that. Once you get that big of a number and you add another zero, 10 to the 24th is huge compared to 10 to the 23rd even. So just keep that in mind as you're working through these problems. All right, keep going, guys. You got this.